Dear students, today we are going to solve some numericals which are related to transistors. These numericals are important for your GATE examination, NET exam, and some other competitive examination. So let's take an example. This one is the first example. Here the circuit is given over here, and for given circuit calculate the value of beta and VCC. So how to calculate the value of beta and VCC? So according to the circuitry that is given over here, this is your circuitry for NPN transistor is given over here, and this is your base terminal, this is the collector terminal, and this is emitter terminal. So here the current is flowing, this is the base current IB denoted by, this is 20 microampere, and this is your collector resistance. The value is given over here, that is 2.7 kilo ohm, and the current is flowing over here. This is the collector current, because this is the collector terminal, so the current is flowing here. This is collector current, and similarly this is your emitter terminal, so the current will be flowing over here. This is emitter current, and this is the emitter resistance. The value is given over here, 0.68 kilo ohm, and this is the VCE, that is given 7.3 volt over here. Similarly, the emitter voltage is also given over here. This is 2.1 volt. So let's solve this problem now, because we have to find out over here the value of beta, and as we know that the beta will also be equal to this IC upon IP. So this is the formula to calculate the beta. So the IB is already given over here in this circuitry. This is 20 microampere. So we have to calculate over here only the value of IC. So how to calculate the value of IC? So as we know that uh, here VE is given, this is 2.1 volt, and the VE is also equal to IE upon RE. So calculate the value of IE, and this will be equal to VE upon RE. So it will become 3.08 milliampere, and as we know that the collector current will also be equal to the emitter current in the case of transistor. So this emitter current is also equal to the collector current, so the collector current will also be equal to 3.08 milliampere. So now put these values in this equation. So this is the beta is equal to the IC is 3.08 milliampere. So now put this value. This is 3.08 milliampere. Similarly, the IB is already given in that circuitry, that is 20 microampere. So now the put this value and calculate the beta, so it will become 154. So this is the value of beta. Now we have to calculate also the VCC. So now how to calculate this VCC? So, to find out the value of VCC, here we will apply the applying over here KVL. So in this path we will also apply the KVL. So here the equation will become VCC is equal to VCE plus IC into RC plus RE. So here this is the collector current, and this is the VCE, this is IE, and this is RE, and this is RC. So if we will applying over here the KVL, the equation will become this. Now calculate the VCC according to this equation. So put the value of VCE, and VCE is already given over here in the circuitry. This is equal to 7.3 volt. So put this value. Now the next is the collector current. We have already calculated over here. This is 3.08 milliampere. So put this value over here, and similarly here RC plus RE is given already in the circuitry. So the RC is equal to 2.7 kilo ohm and RE is 0.68 kilo ohm. So put this value in this equation. So after calculating, the VCC will be equal to 17.7 volt. So this is the procedure to calculate the value of beta and VCC. Now let's take an example 2. For the CP configuration circuit shown over here, determine IC and VCP. Assume that the transistor to be of silicon. So this is the VE is given is equal to 10 volt. RE is also given 1.5 kilo ohm, and this is your emitter current flowing in this path, and this is your IP current, and this is your IC current, that is collector current, and VCC is given over here. This is equal to 18 volt and RC is equal to 1.2 kilo ohm. So determine the IC and VCB. So let's find out the value of IC and VCB. So again, because as you know that the transistor is of silicon, therefore the VB is equal to 7.7 volt. So applying the KVL to the emitter side loop. So here this is your emitter side loop, and here apply the KVL. So after applying the KVL over here, the equation will become VEE is equal to IE into RE plus VBE. So this is IE into RE, and here VEE is given. So this is VEE is equal to IE into RE plus VBE. This is your VBE. So this is after put the value that is already given over here, and after calculating, the IE is equal to 6.2 milliampere. So VEE is already given, that is 10 volt. Similarly, VBE is already because here the transistor is of silicon, so the VB is equal to 0.7 volt, and RE is given over here 1.5 kilo ohm. So put this value, so it will become 6.2 milliampere. And as you know that this collector current is also equal to the emitter current in the case of transistor. So the IC is also equal to 6.2 milliampere. Now applying the KVL to the collector side loop. So this is your collector side, and after applying the KVL, the equation will become VCC is equal to IC into RC plus VCB. So here this is VCC, and this VCC is equal to IC because the current is flowing away. This is collector current. So VCC is equal to IC into RC and plus VCB, because here the VCB is given. So this now put the value. VCB is equal to VCC minus IC into RC. So VCC is already given 18 volt. So put this VCC value. This is 18 volt minus IC into RC. So it this IC we have already calculated. This IC, this is the collector current. This is 6.2 milliampere. So put this value, and RC. So RC is already given. This is 1.2 kilo ohm. So put this value in this equation, and after calculating, the VCB will be equal to 10.56 volt. So According to this procedure, we can calculate the value of IC and VCB. Now, this is your next example. In a certain transistor, IC is equal to 0.98 milliampere and IB is equal to 0.05 milliampere. Determine the value of IE, alpha and beta. So here IE is equal to IC plus IB. As you know that this is equal to, the emitter current is also equal to IC plus IB. So IE is equal to, the IC is already given over here. This is 0.98 milliampere. So put this value in this equation. This is 0.98 milliampere plus IB is also given over here. This is 0.05 milliampere. So put this value, and the emitter current is, after calculating, this will become 1.03 milliampere. So we can calculate the emitter current using this formula. Now let's calculate the value of beta, alpha and beta. So to calculate the value of alpha, the formula is equal to IC upon IE. So the collector current is already given. This is 0.98 upon IE is, we have already calculated over here. This is 1.03 milliampere. So now the alpha is equal to 0.95. Similarly, to calculate the value of beta, the formula is equal to IC upon IP. So the collector current is equal to 0.98 and the IP is equal to 0.05. This is given over here. So after calculating this, the beta is equal to 19.6. So according to this formula, you can calculate the value of alpha, beta and emitter current IE. Now let's take an example, another example. What minimum base current IB is required to derive the given circuit into saturation. Assume that the collector emitter voltage is equal to 0.2 volt and the beta is equal to 50. So how to calculate the minimum base current? The circuitry is given over here. This is your VCC and this is equal to 3 volt. This is your collector current and this is your collector resistance. So the value of collector resistance is given over here. This is 1 kilo ohm. Similarly, here this is your base current and this is your NPN transistor. So calculate the base current. As you know that the beta is equal to IC upon IB and the IB is also equal to IC upon IB according to this formula. So to calculate the IB, the formula is equal to IC upon beta. So the beta is already given over here. This is 50 and the VC saturation voltage is also given over here, 0.2 volt. So calculate the collector current. This is equal to VCC minus VCE saturation upon RC. So it will become equal to, the VCC is equal to 3 volt is already given over here. This is 3 volt and VCE saturation voltage is given in that circuitry, that is 0.2 upon the collector resistance is also given over here. This is 1 kilo ohm. So put these values and you can find out the collector current IC. So this is equal to 2.8 milliampere. And now next, to calculate the IP, this is equal to IC upon beta and here we have already calculated the collector current IC and this is equal to 2.8 milliampere. So put this value upon beta is already given. This is 50. So after calculating the minimum base current will be equal to 56 microampere. Now let's take the another example. This is example for the circuit shown in given figure. Determine the power dissipation in the transistor. So how to determine the power dissipation? Using the formula. The power dissipation, to calculate the formula is equal to IC into VCE. So to calculate the power dissipation, first you have to calculate the collector current. So how to calculate this collector current? Uh, to do this, first you have to apply the KCL to the input loop. So apply the KCL over here in the circuitry, and the equation will become VPP minus IB into RB minus VB is equal to 0. So here this is your VBB minus this is your IB current in this is the base current into RB minus VBE is equal to 0. So this is your in this loop you have to apply the KVL. So the equation is equal to, now you can also rewrite this equation, VBB minus VBE is equal to IB into RB. So the IB is equal to VBB minus VBE upon RB, and this is equal to VBB is given over here. This is 2 volt, so put this value, minus VBE is because this is the transistor uh, here this is based on silicon, so the value is VB is equal to 0.7 upon RB is also given over here 10 kilo ohm, so put this value, and after this you can calculate the base current. So the base current is equal to 0.13 milliampere. So here to calculate the collector current, as you know that beta is equal to IC upon IB. So you can calculate the collector current, that is equal to beta into IB. So the beta is equal to 75 into 0.13 milliampere. So beta is already given over here. This is 75. So this beta is 75 into IB. Here we have already calculated the IB. This is 0.13 milliampere. So it will become 9.75 milliampere. So the collector current is 9.75 milliampere. Now next calculate the VCE. So how to calculate the VCE? Again you have to apply the KVL, and the equation will become VCE is equal to VCC minus IC into RC in this path. So this is equal to VCC is given over here 10 volt minus IC, this is 9.75 milliampere into RC is this one 1 kilo ohm. So the VC is equal to 0.25 volt. So now calculate the power dissipation. So the formula is IC into VCE. So now put these values. The IC is equal to 9.75 milliampere, and VCE is equal to 0.25 volt. So the power dissipation is equal to 2.43 milliwatt. So these are some important numericals. Thank you for watching.